Hello, friends. I know that I went over these in class, but I also know that it's hard to concentrate, and for some of you, it's hard to keep up, hard to listen, process, and all of that at the same time. So I am just going to make a video of me going through them. That way you can watch maybe the parts that you need help with, or watch it a little more slowly or at a time where you're able to focus a little bit better. So I'm just going to walk through here, and this is just going through step by step. The first thing is conversion, keeping in mind that my conversion factor is this. And so I'm going to use that. Here I'm starting with radians. So I have 16 pi over 15. In order to switch to degrees, I need to put the radians part on the bottom and the degree part on the top. Pi's cancel. And I'm just taking my calculator, 16 times 180 divided by 15, and that turns out to be 192 degrees. Here I'm starting with degrees, and so when I go to do my conversion, I put the degree portion of my conversion on the bottom. The degrees cancel out, and I really just reduce this. So I go 288 over 180, math, enter, enter. And that reduces that down to 8/5. And so I still have this pi because sorry, that's so messy. I am writing my answer as fractions of pi. All right, so conversion, we got that. Now we're trying to figure out which quadrant an angle is in. So this goes back to thinking about the quadrants and what's positive where. And it also ties back to what is x, what is y, and so on. So there's a lot of concepts in this, keeping in mind that x is now our cosine, y is now our sine, tan is now a combination of those two. Whatever sine plus or minus cosine has, secant will do the same. Whatever sine has, cosecant will do the same. And whatever tangent has for a plus minus sign, cotangent will do the same. So if you take this one at a time, you have to kind of think, this is tangent. I have a negative tangent. Keeping in mind that in quadrant 1, both my x and my y are positive, so the combination of the two when you divide would be positive for tangent. In this quadrant, my x is negative, y is positive, so when I do the y over the x, I get a negative tangent. Down here, I have a negative x and a negative y, so combining them with division, I'd get a positive because they'd cancel out. And over here, I'd have a positive x and a negative y, so again, their combination would be negative. So I'm talking about it in terms of x and y because that's easier, but in the end, it'll talk to me about it in the trig functions. So when it says tangent, I look at my tangents and I say, okay, well, the only two quadrants where tangent's negative would be over here and down here. That's what meets this requirement. This is secant. Okay, so secant is related to cosine, which is the same as x, and they're telling me it's less than 0. So they're telling me that the secant is negative, which means my cosine would be negative, which means I'm looking for a place that has a negative x. Okay, well, the x is negative here and here, but we're looking for something that is both. And so in this quadrant, both things happen. I have a negative tangent and I have a negative x. So that is quadrant 2, and that is my answer. So it's a super simple answer, but I have to really think my way through that. Okay, find all 6 trig values for a given triangle. Exact answers, no decimals. Alrighty, so first of all, they're asking me about angle A, I can see in the problems down here. Oops, and so I am going to kind of think, okay, this is my opposite, this is my adjacent, and I'm going to need my hypotenuse. I'll be using SOHCAHTOA, and that will help me find sine, cosine, and tangent. And then I'm going to just kind of remember that sine goes with cosecant, cosine flips over, becomes secant, and tangent flips over to become the cotangent. So if I can remember whose partners with whom, then I can just flip over my first 3 answers to get my last 3 answers. So first of all, we need the third side of the triangle, and we don't have that. So we're going to need to take 8 squared plus 5 squared to get our hypotenuse squared. So that'll be 64 plus 25, oops, sorry, equals h squared. So that's going to be 89. So my h is going to be the square root of 89. And I'm trying to think if any perfect squares go into 89, and I don't think so. So that means I just have to leave this as the square root of 89. And since it says exact answers, I can't change that to a decimal. And some of you are going to do that on the test. It's going to say no decimals, and you're going to write a decimal, and you're going to end up getting it wrong. So pay attention to those details. Now we just go through and do what we know from SOHCAHTOA. So when it asks me for the sign, I put the opposite. Okay, some of these are going to get messy. I put the opposite over the hypotenuse. Now that's kind of messy because I have to rationalize the denominator, but I'm going to sneak over here and do cosecant right away. Because what cosecant does is it flips over the sign, and so then I've got that one done already. But when I rationalize this, I don't have a ton of room here, so I'm going to show you the work and then erase it for my answer. I would have to multiply the top and bottom by that root 89. So when I'm all done with this first one, I'm going to have the 8 that was on top, root 89, over 89. And then because the 8 and the 89 don't reduce, I'm done. And the reason I flipped this over right away is then I don't have to rationalize it again. Because if I took this answer that I've got now and flipped it over, it would get really messy, even more so than the other one did. How about cosine? Cosine is adjacent over hypotenuse. So I'm going to sneak over here and do secant, its partner, root 89 over 5. I'm just going to flip that over. When I rationalize this one by doing the same thing as I did before, that will on the bottom turn into, that'll turn into 5 on the top from my adjacent, root 89 from rationalizing over 89. And again, the regular 5 and the regular 89 don't reduce, so I'm done. Tangent, thankfully, is going to be easier. Opposite over adjacent. Opposite side is 8, adjacent side is 5. Then I sneak over here to cotangent and simply flip my answer over. So I can get all 6 of them by knowing the first 3 of them. Okay, so now I'm doing the same type of thing. I'm finding all my 6 trig values, but this time I'm going to start on the unit circle. So it says use exact answers, no decimals. All right. Well, they're all asking me about 30. So if I think about where I am, okay, that's my dog. Hang on. Hey. Okay, so it's 11 at night and they are shoveling the sidewalk at my townhouse, and so my dogs are going to bark at them. So that's awesome. Okay, anyway, if you go to 30 degrees on your unit circle, the coordinates you should see would be root 3 over 2 for your x, or cosine 1 over 2 for your y. That's not mysterious. That's on the unit circle, just like it says unit circle. Okay, so the sine is my y value. So that's 1/2. Again, I'm just going to sneak over here to cosecant and get 2 over 1. Now my dog's getting a really loud drink right by me. This is going smoothly. How about cosine? Well, cosine is equivalent to x. So root 3 over 2. That's going to be related to secant. I have to flip that over. So 2 over root 3. Cinder, come here. Rationalizing that, I end up with 2 root 3 over 3. And then tangent is tricky. You can use the tangent boxes if you want to. And if you're using your tangent box unit circle, you should be able to see that's root 3 over 3. if you don't know what I'm talking about, you can use it says unit circle filled in with tangent boxes. It's in the filled in notes, and it does the work for you. It takes your y, puts it over your x, then multiplies by the reciprocal and rationalizes. So it gives you the answer without you having to do all that work every single time. And then once I know my tangent, I can go ahead and find my cotangent, which is going to, okay, and then now that's my washing machine going off. Take my tangent, which was this, flip it over. Then I have to rationalize that. So I get 3 root 3 over 3. They cancel, and root 3 is my final answer. So again, this is not going to be a lot of calculation, but it's a lot of understanding and tying things together that can be pretty tricky. Now this next section, I put all of these in purple because they're all really doing the same thing. Finding the sides, finding the angles, and solving. Solving simply means you're going to find all the sides and angles. So sometimes you'll be using SOHCAHTOA, you'll be using inverse. We also are going to use the fact that the angles total 180. And we're going to use the fact that a squared plus b squared equals c squared. This will help us to find side 3. This will help us to find angle 3 once we know 2 of them. So I just have 2 examples that kind of cover all of those things. This is to solve the triangle, finding all the angles and all of the sides. Across from angle A is side A, across from angle B, side B, across from angle C, side C. What do I know? I know that's 90. What do I know? I know that's 35. This one, I know 2 out of the 3, so I can do my angles and say I'm just going to use subtraction to find that last one. And so when I do that, then this angle B must be 55 degrees. And that was not trig. I did not have to find that using trig because I already knew 2 of them. Side A, they told me, was 3. So I need to find these other 2 sides. When I'm trying to find side 3, meaning the last one, I can go ahead and use Pythagorean theorem, but not until I know 1 more. So let's go ahead and find side B. Okay, well, I know this angle. I know this side, which is the opposite, and I'm looking for side B, which is the adjacent. So thinking back to SOHCAHTOA, opposite and adjacent means I'm going to use the tangent of 35 equals the opposite over the adjacent. And then these, if you want to think of it as cross multiplying, you can. If you can just kind of manipulate that in your brain so that you know you're going to end up taking 3 divided by the tangent of 35, that's awesome. Make sure that when you go to do that, your calculator's in radian mode. So I would have 3 divided by the tangent of 35, and that tells me that this is about a 4.3 unit long angle. Excuse me, side. And then to do the last part, I can just go ahead and do my a squared plus b squared. So I can take 3 squared plus 4.3 squared to get c squared. So I'm going to have 9 plus 4.3 squared. And then I'm going to square root, because this comes out to be about 27.49. I'm going to square root that. And c is 5.2. All right. How about here? This is the word problems. A 10-foot ladder is leaning against a tree. It hits the tree 8 feet from the base. What is the angle between the ground and the ladder? Okay, draw a triangle because you always know that's going to be the case. Which one's the ladder? This guy over here, 10 feet. What's the tree? This guy right here. It hit up 8 feet. It's asking what is the angle between the ground, which is this, and the ladder, which is this. And it's looking for an angle, so I need to be using inverse. Because this 8 is straight across from, so the opposite side, and the 10 is my hypotenuse, thinking back to SOHCAHTOA, I'll be using sine inverse and asking my calculator to find me the angle that would have an 8/10 for the sine value. So I do second sine 8/10, and it tells me that's about a 53.1 degree angle. So these two examples kind of tie back to all of these. These are all very similar, but that's definitely something you want to go back and practice from your worksheets. All right, hang in there. We're going to wrap this up. This says to go to my calculator. Be really careful about your mode. I can see this one's degree mode. I can see this is degree mode, even though degree is really in a weird spot. And I can see that this is radian. So I'm going to do the two that are in degree mode first. I literally can type this one straight in, cosine 27. And it tells me I'm supposed to do 3 decimal places, so 0.891 is going to be the cosine. This one's tricky because it's cosecant, which is not on there, but keep in mind you want to be able to think that flips over the sine. So I'm going to go 1 divided by, and then type in sine 72. And the degree mark there is in a weird spot too. Awesome. So I'm getting 1.051. And again, it said 3 decimal places, so that's what I did. Now I have to go to mode, change to radian, and then I'm going to type in tangent 3 pi over 7. And it's going to tell me that 4.381 would be the tangent value. So that's straight up calculator, and the thing to pay attention to there is mode and these weird ones where you'd have to know which thing to flip over because we only have a sine, cosine, tangent button on our calculators. And the moment you've been waiting for, the last one. So this is what we did in 4.4. It's asking me to find the secant. Okay, let me think about what that's going to mean. Secant flips over the cosine. Okay, so I'm going to be flipping over the x once I find it. First, I need to draw a triangle. This is telling me that I'm between pi and 3 pi halves. Okay, well, that means my triangle that has to go like from the bow tie, remember, is in this quadrant. And this is the angle in question. So this is my cosine, meaning this is adjacent over hypotenuse. So the adjacent is a 4, hypotenuse is a 5. One of those is negative because it says so up here, so it has to be the negative. Keeping in mind that your y value in this quadrant will also be negative. We are supposed to use a squared plus b squared equals c squared, and I'm ignoring the negatives because when you square things, the negatives go away. So this will be 16, this will be 25, and most of you already know this is going to turn out to be a 3. So awesome. This part turns out to be 3, but you have to be smart enough to say, hey, I know I'm down here in quadrant 3, so my y would have to be negative. Now, from this angle, this is now my opposite, adjacent, hypotenuse. So since I'm going to be flipping over cosine, which is usually adjacent over hypotenuse, the secant is going to be the hypotenuse over the adjacent, or you could type it as -5/4. Okay, so that is a lot. And so there's a lot of different topics and a lot of things to remember, but hopefully this will allow you guys to watch just the parts that you need. Which is probably not the parts where my dog was barking, or she was taking a drink, or where the laundry was making that noise. So I apologize for all that. It's all the beauty of teaching from home. Have a great day, guys. See you soon.